it seems to me from the outside, they've always been very keen on solving real practical problems, and that's actually a very strong agenda. Sometimes it makes it puts very tight requirements on the kind of technology. It has to actually work. It has to be simple and robust. It forces attention into areas which are difficult to actually work in. I mean, putting robots in mines means you have to know how to go into a mine, which I respect. That's actually a very difficult, messy, hard problem to face as your daily job.
Field Robotics Center is doing a lot of stuff in autonomous vehicles, putting robots into mines, doing stuff with like landing a helicopter on a boat. There's also a lot of agriculture stuff going on. So I think there's an orange picking project and an apple picking project. I don't know. They're not the same project. It's robots that are getting out and doing real stuff in the real world. And it's distinct from like a service robotics or a medical robotics.
In some respects, I think it's been interesting watching the level of sophistication in autonomy steadily increase. To begin with, if you're going to try to solve a problem, you always try to solve it in the simplest possible way. And the solution might not be as advanced as your colleagues in the lab can do, because you're facing very different constraints. You're having to actually put a robot out in the agricultural field. But in the end, you test your ideas against the reality of dust and light and GPS errors or whatever other problems there are, and you learn a different lesson. I think it's a very good lesson. Not everyone should work on problems that are completely practical. There's a role for solving problems which are more theoretical and trying to open up different kind of intellectual territory, which you probably wouldn't get to if you were always trying to solve the constraints of some practical task. But I think one of the strengths of this place is that we have a big tent. We can have everyone. We have people who are really just trying to solve a real problem and then uncovering questions that no one else would have asked.
There's been a lot of automated mining vehicles for a lot of the big strip mining type operations, where those vehicles are just a whole lot bigger than anything you see on a day-to-day basis. I mean, it's not your dump truck that can drive down the road. It's a lot bigger than that. If you have a machine like that breaks down and stops operating, every minute that it's not operating, you're losing money. So it's important to keep that working. Then there's also been robots that go down into underground mines. And in that case, you can send a robot in places where it's not safe for a human to go. The robot has sensors. You can put lights and cameras on it. You can put lasers on it. And you can get a lot of information, both the images of what it looks like down there, and then also with laser data, you can get a 3D picture of what's going on in the mine.
The FRC also it's been obvious that they've managed to keep together big teams working on problems together, which is, I think, overall not all that common in academia, and certainly not in this university. People come together in groups of a few faculty or a few students, but these large coordinated teams, that's its own miracle, getting a lot of people to work together when they each have their own interests. And for grad students, they each have to, at the end of the day, show a unique individual contribution. We assume machines will surpass us. It's certainly true that on a factory line, stuffing microscopically small capacitors onto a circuit board, a machine is way better than we are. So, part of what I see in this shift is that we're now addressing much harder problems. The factory is a controlled environment with kind of known resources. The real world, be it your house or the moon or a field in Kansas, is a messy, uncontrolled place. And so the problems are just a big step harder.
You have to be much more robust than what you can do in a lab. If your robot is in the lab for its entire life, you can always reset it. You can always, pop in a new set of batteries, that kind of thing. If it's out there doing a job in the real world, and especially space robotics, once you let it go, it's hands off. It has to do its job well.
Technology can exist, but technology is really our handed down from person to person. I mean, knowledge about how to solve certain problems is institutional. And you can read all the papers of another group, but still not really know how to do what they do. Like, there's no secret there. It's not that people are necessarily hiding like specific details when they write about things or they document what they've done. But, human knowledge is a fuzzy, individual, intuitive thing. And that's best conveyed working with people directly. So what I see is bringing a larger community of people who are really knowledgeable about the problems of space robots or, under one roof, and then maintaining that group so that students come in, they learn, they go off to do other things. That knowledge the experience is transmitted. Will build upon what is very likely a long cultural success of the Field Robotics Center at building groups and maintaining that knowledge over time. The knowledge that we create is a lot more than just the papers we write, than the video we shoot, than the demos we make. It's passed person to person, and understanding how to sustain that over a long time and over the career of longer than any one individual's career is part of what makes an institution grow in the long run.